My name is Steve Cosenza. I'm the tech lead of the Finatra and Data API teams here at Twitter. And tonight I'm going to be talking about some of the exciting new features of Finatra version 2. So what is Finatra? Finatra is a framework for easily building API services on top of Twitter's Scala stack. Currently, we support HTTP services, and this you'll be familiar with if you've used Finatra V1. But we are also planning to support thrift services in the future. First, brief project history. Finatra V1 was started as a GitHub project in early 2012 by two Twitter engineers, Chris Burnett, who's here tonight, and Julio Capote. In the middle of 2014, myself and Chris Coca, working on the Data API team, released Finatra version 2 internally at Twitter. It was a snapshot release. Beginning of this year, Finatra V1 had their final release. This was supporting Scala 2.9 and Scala 2.10. And then this talk ends up being well-timed in that we just released the first milestone of Finatra V2 to Maven Central just about an hour ago. And we have now merged. Thank you. And we've also merged the version 2 line of code into the master branch of Finatra's GitHub page. Some highlights. Finatra V2 is a complete rewrite from the ground up, but we worked with the Finatra V1 engineers to maintain the simple spirit that made Finatra V1 so popular. And some internal benchmarks of, let's say, GET requests returning JSON objects. Finatra V2 was about 50 times faster than its predecessor. V2 comes with powerful feature and integration testing support, and I'll be talking about some of these details later in the presentation. Finatra V2 now supports JSR 330 dependency injection annotations for use throughout your service. We've chosen to use Google Juice as our implementation of those annotations, but it's worth noting that it's completely optional to use these annotations or Juice at all in writing your Finatra service. However, if you do choose to use them, you'll find excellent support provided throughout. We now integrate with Jackson for seamless JSON parsing. Again, this is optional, but if you choose to use it, you'll find some enhancements to the Jackson Scala module, which includes support for required fields, default values, and also validations of fields. The framework now uses SLF4J for all framework logging, and optionally, if you choose to use Logback as your implementation, we provide an integration with Finagle Futures that'll let you do map diagnostic contra attributes and have them propagate across futures. Finatra is now built on a library that we're also releasing called Twitter Inject. And this library provides the integration points of dependency injection with common Finagle classes and Twitter server classes. And you can see the names of the libraries up here. And these are usable outside Finatra as well. Finatra is now decomposed into several libraries. At the top of the screen, you'll see Finatra HTTP. This is the main dependency you would use to create a Finatra HTTP service. You'll also see our integrations with Jackson, Logback. HTTP client is kind of a bare bones client built on top of Finagle. And Finatra Utils is a grab bag of utilities that we've found useful when creating Finatra services. OK, so let's get right into it and see some concrete examples of Finatra V2 in action. We'll create a simple HTTP API that lets you post tweets. But first, before we start writing some code, let's create a feature test first. So feature tests are a form of black box testing where we start a locally running server and issue actual HTTP requests and assert actual HTTP responses that are returned. In this way, we test the externally visible features of the API, hence the name feature testing. With the feature test, the main class that we use is embedded HTTP server, and we hand that a Twitter server. In this case, since we haven't created a Twitter server yet, we just pass an anonymous HTTP server to it. We then specify in the test that we'd like to issue an HTTP post. The path is /tweet. The post body, you can see here, it's JSON representing a tweet. And then we have a few assertions. The first assertion is that we expect an HTTP 201 created response. And we expect a location header to be present that points at the newly created tweet. So now let's run that test. Before we run it, let's do one additional assertion. Let's also assert that there'll be a JSON body returned back to us. And in this case, it's going to mirror the same JSON that was posted, except there's an additional ID field, the ID of the tweet that was created. Now let's run the test. OK, so as expected, the test fails. But let's look at the test output. So you'll see a post was issued to /tweet. Here are the headers that were sent. Note that we posted a content type of application JSON. Here's the post body. And now everything between this equals and this minus line, these are all log messages that the server's output while processing this request. So in this case, the routing service said, I can't find any routes for posts to /tweet. And then finally, down here is what the service actually returned to us. It returned a not found with an empty body. So in order to get this test passing, now we can create a controller. Controllers extend the controller class, and they follow the Sinatra style. HTTP method, route definition, and then a callback to handle that request. In this case, we directly take in a finagle HTTP request as our input. And we use a response builder that's provided to us by the controller to create a response. So in this case, we'll return a HTTP 201 created response and a body of hello. Also note that this callback is not returning a future. Of course, if you're calling a blocking API, you definitely want to keep that future throughout. But in this case, if nothing's blocking, you could simply return the response directly, and Finatra will take care of converting it into a future. OK, so now that we have a controller, we can now create a server. Servers now extend the HTTP server class. You then override a configure HTTP method. It hands you an HTTP router. And you can now add things such as filters or controllers to this router. In this example, we're demonstrating two APIs. The first is an API where you could pass a type directly to the router. And then Finatra is in charge of creating that type for you. And in the bottom case, we knew up our controller ourselves. And in this API, you pass in the instance, and it uses it directly. And a little bit later in the presentation, I'll show an example where we use a type for the controller. Now that we have a real controller and a real server, we add our real server to our feature test. Then rerun it. And now you could see the test is failing, but for a different reason. In this case, it's saying an unrecognized token of hello was found. This is because we specified a JSON body was the expected response, and hello is not valid JSON. Also notice at the bottom, we'll print both the received response bodies and the expected response bodies on single lines. And this little asterisk, that tells us the point at which those lines diverge. So in this example, it's not that useful. But you can imagine if you had a single character that was different, that asterisk can help you. OK, so in our continuing effort to get this test passing, let's now parse some JSON and generate some real JSON. So as I mentioned earlier, we provide an integration with Jackson. If you choose to use it, the basic premise is that you create a case class that mimics the JSON that you want to parse. So at the top of the screen, you could see the JSON representing a tweet. And over here, you could see we created a case class called posted tweet. that has the same field names as the JSON. Worth noting is that latitude in this case is posted to us as a JSON string, but in the location object, it's a double. So Jackson will take care of doing all the value conversions for you. Also worth mentioning is that since we now support required versus optional fields, if message is not included, since it's not an option, that is a validation error, where Jackson normally would return a null in that field. If you do have an optional field, let's say location is omitted in the JSON, a none value will end up in your case class. And then for the sensitive field, if that's not in your JSON, the default value of false will be used. Also worth noting, Finatra comes with a default Jackson configuration, but this is completely customizable. Now that we have a case class to represent our posted tweet, we can update our controller's callback. Notice now, instead of this being a finagle HTTP request, it's our case class directly. And Finatra will take care of posting the request into this object. We'll also, for now, just directly return that posted tweet in our created response body. Rerun the test, and now you see it fails because the ID is missing. So by returning that case class, Finatra turned that case class into JSON. It was parsed as JSON. The JSON diff failed, and we're now missing the ID. OK, so let's generate some JSON now. To generate JSON, it's the same pattern as parsing JSON. Create a case class to represent the JSON you'd like to generate. It's worth noting that you can use the same case class to parse, use throughout your services, and also produce your JSON. But we've found that if you separate those concerns, you get a lot more flexibility in being able to refactor your domain objects, but maintain a backwards compatible API in what you're parsing and what you're generating. So in this case, we'll create a serialized tweet case class. Looks the same as the other one, except now we add an ID field. And notice that ID field, it's a status ID type. That status ID, it's a case class that extends this wrapped value trait. And what this does is signal to Jackson that I really want you to treat this as the wrapped string inside of it. So I want you to parse it and generate it just as that string. But now within your application, you could pass around a status ID instead of just an untyped string. OK, so now we'll update the controller to use this new tweet. And what we'll do now is we'll just create a hard-coded status ID with 1, 2, 3. Let's assume for this example that we already have a status case class. It's the main kind of domain object that we use throughout services at Twitter. We'll take the posted tweet, turn that into our domain object, passing in the status ID, get a status out. Here's where we will be saving our status ID in a future slide. When we're done, we create a renderable tweet from that domain object, and then we put that in our created response body. So rerun that test, and yay, it succeeds. And as you can see here, a created was returned with the JSON body we expected. OK, so at this point, let's take a brief break from that main feature test to write some additional feature tests that test some edge cases and different types of JSON that may be posted to us. So the first edge case will be, let's say message field is not specified in the JSON. Run that test, and you'll see it immediately succeeds. We get a 400 bad request returned, and there is a response body with some JSON that indicates the message field is a required field. So this type of error response, it's the default error that you'll get out of Finatra, but it's completely customizable. Let's write additional tests, a test for some invalid values. In this case, we have a message field, but it's empty. And for latitude, we specify a value that's not valid. We run that test, and this test fails. It fails because we expected a bad request, but it created a tweet for us anyway, and it used these invalid values. So if we want Finatra to be able to return a bad request in this case, we have to add some additional hints that indicate what type of values are valid. And for this, we use a new Finatra V2 feature called validation annotations. Out of the box, Finatra comes with the following validation annotations, and it's easy to create your own. So let's update our case class to use these validation annotations. At the top of the screen, we'll add the @size validation to our message string and specify that it has to be at least 1 character, but a max of 140. And then for our location, we'll use the @range validation to specify a valid range for latitude and longitude. So you could think of @size as being used for types that would have sizes, so things like strings or sequences, and @range for being used for ranges of values.
Does it mean I cannot tweet from the North Pole?
Maybe? No, I believe actually these are valid values. Yes. All right, so now with these validation annotations, rerun the test, and you'll see it succeeds. Note now in our error response, we indicate both validation errors, both that message size is not between our expected and the latitude is not between our expected. So we collect all the different validation errors and we don't fail fast. So now let's go back to our original feature test and try to actually save this tweet off. And to do this, we're going to use a cloud-based database named Firebase. So we're going to create a class that will let us save a tweet. And this class is going to enlist the help of 2 other classes. The ID service, which will allow us to ask for the next tweet ID, and a Firebase client that will let us talk to our database. And to gain access to these dependencies, we'll use the JSR 330 dependency injection annotation called @inject. So by putting @inject on this class's constructor, we're signaling to Finatra that when you create this service for us, provide us these dependencies. We'll also add an @singleton to the service class, and that signals that we only want a single service to be created for the entire Finatra server. Now, it's worth noting at this point that the JSR 330 annotations, they're available in a standalone jar. It's very small, and it only specifies a few annotations and a few interfaces. So if someone does not want to use a JSR 330 compatible runtime to create this class, they're free to new it up themselves and pass in those dependencies in the constructor. So you could think of this as being a nice, unobtrusive way of declaring your dependencies, and then if you'd like the framework Finatra to use them, you can. All right, so now similar to the tweet service, we'll inject the tweet service into our controller. It's the same pattern. You add an @inject to the controller's constructor, and we'll also add an @singleton, indicating we only want a single controller per Finatra server. We'll then update our server. At the top of the screen, you could see the server before, where we manually created our controller and passed it into the router. And on the bottom of the screen, you'll see we now pass in the controller by type. And this signals to Finatra, you create it, and if there are @inject annotations on it, also take care to create those classes and pass them in. You'll also notice that we provide a sequence of modules. These are juice modules that, if needed, can provide additional configuration, which is needed to create some of the classes that you need. So in this case, we have to provide a module that says how to create a Firebase client. So here's an example of what that Firebase client looks like. And the reason why we need this client is we have to specify where the actual Firebase external service is located. So we'll extend an HTTP client module. This is provided in the Finatra HTTP client library. And you could then specify a destination and a retry policy. And destination, this is a finagle destination value. We say we'd like you to use the flag resolver. So this will allow you to specify where Firebase is located in a finagle flag. OK, so we're now going to rerun our original test. It's on screen. And now this test that was previously passing, it now fails. The reason it now fails is when it tried to do the put to Firebase, it failed and said no hosts are available for flag Firebase. And the reason is we didn't specify a location for Firebase. However, since we want this feature test to be able to be run locally, we want it to be deterministic, we want to be able to run it in CI, we're going to need to mock out that Firebase client call. So here's how we do that. So at the top of the screen, here's our feature test before. And at the bottom of the screen, we now use a Finatra trait called feature test. By using this feature test trait, we make it easy to override classes in the server with things like, let's say, mocks. So in this example, by including this feature test and adding this module to our server, we can then @bind different values. So we could say the Firebase client that your server wants, we want you to use a smart mock created by Mockito, and then we want the server to use that. Similarly, create a smart mock for the ID service and then bind that into the server. So we now have a locally running server where we're able to selectively swap out classes in a test. Here's now that test with the @binds. Now in our post tweet, we'll use the mock ID service, and we'll stub out the desired response. So in this case, when getID is called, return a future with a status ID of 123. And when Firebase client put is called to this path with a status object that we expect, return a successful feature. Now we could rerun this feature test, and it'll now pass. So we now have a test of the locally running server. It's end-to-end, and it relies on 0 external dependencies. OK, I'd like to introduce one additional testing type, and this is called a startup test. Startup tests look pretty similar to feature tests, but their goals are slightly different in that you want to avoid override modules or mocks. You basically want your service to be as close to production as possible. And what this allows us to do is, in a test, verify that our entire object graph is correct and fully specified. You'll notice we now specify stage equals production. This signals to Finatra and Juice to eagerly create the entire object graph at startup time. This is what we do in production, but normally in feature tests, we lazily create these. Well, also, you'll notice we're passing in a command line flag, and we're passing in the Twitter server resolver map flag. And as the value of that flag, we say, hey, Firebase, we want you to be equal to the nil resolver. And the nil resolver is essentially an empty list of hosts. And by specifying this empty list of hosts, we now allow the server to start up completely without having to connect to any external systems. Our test then says, server, assert that you're healthy. This will poll the server, wait for it to completely start up, check its health endpoint that's provided to us from Twitter server, and make sure that everything came up completely. At the end of the day, we've found great value in using startup tests with Juice and creating our services. And the way to think about it is Juice provides lots of modularity benefits and testing benefits, but it comes at the cost of full compile time safety. However, with a startup test, we can mitigate lots of those costs. You don't get the error immediately at compile time, but as soon as you're running your test suite, you immediately see that error. It tells you what's wrong. And kind of by including both of these, we feel you get the best of both worlds. OK, I'm going to briefly go through some additional V2 features. We support message body readers and writers. These allow you to deal with just your domain object as the input of your route and the output of your route. But it'll take care of, in this example, taking your status object and turning that into the serialized tweet. We fully support declarative request parsing. So this is really similar to how we parse JSON. You could also use this for things like GET requests. So in the top of the example, you'll see we create a custom case class. The route param of ID will be parsed into a status ID object. An expand query param will be parsed into a Boolean. You could do all the validations that I showed in a previous slide. All the type conversions will be done for you. We support required versus optional, and we also support default values. If you're using Twitter util flags, we have an @flag annotation that lets you inject the value of those flags anywhere throughout your application. We fully support mustache templates. We now have a @mustache annotation. You could throw it on a case class, return that case class from your controller, and then the name of your mustache template, it'll be routed to that template and serialized out. We have support for two types of server warmup. The first, if you set that flag to true, your server will not start accepting incoming requests until all Finagle clients have been resolved. So this is really important if you're connecting, let's say, to a backend thrift service. There's a few hundred or a few thousand nodes. It takes a while to do that resolution. And then we also have a warmup method. Override that warmup method, add any application-specific warmup logic, exercise different controller paths, different services, and give the JVM time to warm up. And finally, I wanted to show that feature tests are not limited to a single server. You can bring up multiple servers, especially if those servers have dependencies on each other. So in this example, we have an HTTP server that calls a backend thrift server. We could create both in the feature test, tell the HTTP server with the resolver map, when you try to resolve the echo service, point at this thrift server's external point. And then both of these servers will be wired together. You could run a feature test that runs through both of them. So that's all I have for tonight. I'd like to thank the Finatra team that contributed to Finatra V2 on screen. And I'll leave you with the server and controller from the example and open it up to questions.
In Finatra 2, do you guys support automatically registering Finagle stats to all of the routes and things that are defined and the methods?
So you'll notice the common filters. One of those filters will give you Finagle stats for all requests, error responses, and stuff like that. We don't currently support per route stats, but that is something that's on our backlog. But you are free now to create a filter that would do that. But yeah, great question.
Do you have any experience or good case studies where you've used this or the previous version to implement hypermedia APIs for marshalling Jackson into maybe a higher level object that has linking and other kinds of descriptive metadata?
Yeah, great question. We do not directly have experience with that with Finatra, but using something like a message body writer would allow you to return kind of any type of object you like and then serialize that as you wish. But yeah, no direct support, but certainly could be something that could be added.
I wanted to say, cool, this is awesome, but another question I had, when you were newing up embedded HTTP server,
Yeah.
I believe the actual parameter name was Twitter server.
Yes.
It seems sort of unfortunate.
Yes.
Anyway.
So yeah, great question. The reason for that is you actually can specify any Twitter server in that location. So let's say you want to be a Twitter server and you want to directly use Finagle to create your HTTP server, or even let's say use something like Finch. You could still use this test class to start up the server locally and then issue requests and responses.
Okay, thanks.
Yeah. Good catch, though.
I guess that probably answers my question. How about WebSockets, or is that something you would do with a lower level version?
Great question. We do not currently add any additional support on top of Finagle for WebSockets, but as we start to use Speedy and HTTP 2 more, I would expect to see some of those features.
Hi, do you have any support for Swagger?
That is a great question. We currently have a experimental directory in-house where we actually had a proof of concept where we generated Swagger UI based on the controllers and routes. So when you're doing the declarative parsing, it's actually really great to implement something like that because you're fully specifying kind of all the query params, route params, what the types are. So it's very doable, but yes, not currently completely working. But that is something that, yeah, if the community is interested in, we could get that out there, and we would definitely take that as a contribution.
Talk a little bit about the scope of the usage and where.
Sorry, I didn't hear.
Sorry, could you talk about the scope of your usage and contract
So we have many production servers that currently run on V2, and let's see. I guess future versions, future services are coming out, and they are using Finatra V2. So.
Other questions? Okay, thanks, Steve.
Thanks.